All right, guys, so we're going to continue on with the notes. Continuing on with the notes today. We are on, I don't know exactly what page, but we're starting off with 1/4 x squared minus 2. So we should be closer to the back half of the note sheet. Yes. No. Dang. Now, when we look at transformations, we started talking about this yesterday. There are, well, several that we have. We have horizontal translations, moving it left or right. And if it has a left or right movement, it's going to be inside our parentheses, our x minus h squared. Well, erase that there. This here, now most of the ones that we have, we don't have b written in. I put it in here just kind of as a reference point for us to look back at. Because if we have something added or subtracted from x inside parentheses, it's a translation left or right. It's moving left or right, and since it's inside the parentheses, it's the opposite of what we think. Now, in the note sheets, and for the most part, we call this A, where B is at. But if there's a value here, it's going to be horizontal stretch or shrink. And again, just like with our horizontal translation, it's the opposite of what we think. Because if it's given to us as a fraction between 0 and 1, it's going to be a stretch. If it's greater than 1, it's a shrink for horizontal. Now, if that value, or where that B is at, is a negative there, it's a reflection across the y-axis. Our K is our translation, vertical, up or down. When we add something, it's going up or down. And in the last spot, A, if this has a value between 0 and 1, it's a vertical shrink. If it's greater than 1, it's a vertical stretch. And if we have a negative where A is, it's a reflection across the X. So the only time, especially with the A and B's location, if there's a negative in either one of those spots, we're purely talking about reflection with the negative. And if there's a number there other than 1, it's a horizontal or vertical stretch or shrink. Now, this is the problem we left off on. And looking at this problem here, there's two translations. And whenever we talk about the translations, the first ones we want to list every single time is the movement left or right and up or down. And if we look at this here, is there a horizontal translation left or right? Is there something added to the x or subtracted from the x inside the parentheses? No, because we don't have anything added to x or subtracted from it. We don't have this minus h. So that's kind of a trick question. There is no left or right movement because we don't have x plus a number or x minus a number inside the parentheses. But we do have the minus 2, yes? What is that one telling us? It is not horizontal, it's up or, so it's vertical. So how far would we move? Down what? Because with outside the parentheses, that minus 2 is moving exactly like we think it should, which is down 2. So that takes care of that one. And the only other number that we have is the 1/4. Now the 1/4 is being multiplied in front of the x, which means we're talking about stretch or shrink. Now would it be vertical or horizontal? It would be horizontal. And the main way we tell the difference is because of the location of 1/4. Is it inside parentheses or in front of parentheses? It's inside the parentheses, yes? So it's horizontal. If it's in front of x or in front of the parentheses, and we have 1/4, then it is vertical. When it's multiplied by x inside the parentheses like this here, it's going to be horizontal. Now we need to determine if it's a stretch or shrink. Now, 1/4 looks like it should be a shrink, yes? But it's actually a stretch, horizontal stretch, exactly, of 4. We have to flip it. We have to flip it from 1/4 to 4. So this function moves down 2 and has a horizontal stretch of 4. Questions on this here? Let's look at the next one. G of x equals 1/3 x squared. Yes. This because the 1/3 x, 1/3 times the x is the only thing we have changed from x squared. Only thing we have applied to it. Since we don't have anything added or subtracted behind the parentheses, means it's not moving up or down. Since we don't have anything added or subtracted inside the parentheses, means it's not moving left or right. Since we don't have a number in front of the parentheses, means there's no vertical stretch or shrink. So that 1/3 is all we have, and that's our horizontal. Questions on this here? Let's look at this one here. Now, one of the biggest things I will say with any of these here, because we've done these for a little bit, we've done these before, and it's not so much that there's some unique insight into looking at these and knowing which one's which. I am really just referring back to our general form. What is each spot taking place? Because we know if there's a number in front of parentheses that has one of two options. It's either vertical stretch or shrink, or reflection across the x. The way it's a reflection across the x is if that is negative. Do we have a negative in 3 spot? No, it's just +3, yes? So that means reflection across the x-axis is out. It's not a choice. But we do have the 3, which is going to be vertical stretch or shrink. And if we look through the rest of it, we have the x minus 1 inside, yes? The minus 1 is telling me we're moving left or we have a horizontal translation. And if I continue on through, we don't have anything after it, so that means the up and down isn't there. There's not a number or sign in front of the x inside the parentheses, so horizontal stretch or shrink is out. Reflection across the y is out. Do y'all see how that works? And that's really, when I look at these, that's what I'm looking at. It's not so much base off problem. I'm looking through what is taking what spot. Horizontal stretch or shrink, is there a number in front of x inside parentheses? Yes, then we have it. No, we don't have it. And it's just checking those different spots. We'll look at the -1 here first. Well, again, we said the -1 inside is telling me left or right. Where are we going? Because it's -1, opposite of what we think would be right. How far? 1. Questions on how we got to this part here? Now, the only other thing we have is the 3. And we said the 3 is for our what? Vertical stretch or shrink. We only flip horizontal. We do not flip vertical. Since the 3 is greater than 1, it is a stretch. If the number had been between 0 and 1, it would be a shrink. Huh? If it's 1, there is no stretch or shrink. Because in this one here, the number in front of x is indeed 1. Because we don't write it, but I do have 1 times x. So the horizontal stretch or shrink is not changing. And really what this is, and this is a little above and beyond, is really telling us what the x and y values for the function are changing, how we're affecting them from the original graph. So with horizontal stretch of 1, means the x values that are going in, we're multiplying them by a factor of 1. Well, multiplying by 1 doesn't do anything, so there's not an impact on that. And the vertical, our up, down, is affecting the y values. But luckily, we don't have to go into the nitty-gritty of all of that. We're just describing them. And I'm not going to make y'all go through the process of taking several points from the graph, x squared, that one there, and applying these transformations to it to get to the new points. Because we could do that, but we're not going to. Let's look at the next one here. So the plus 2 at the end is one of the transformations, and we can start there. And that is our up and down. And since it's positive, it's telling us it's going up 2. Now, I would always go with up, down, left, right first, so we do have up 2. We have x plus 3 inside the parentheses. The plus 3 tells us we're moving where? Left 3, opposite of what we think. Because it looks like it should go to the right, but we're actually going to the left. Have we taken care of all of our transformations? We still have the negative out front, yes? Yes. It's a reflection. Because if we have a negative in front of the parentheses or in front of x, we're talking reflections. Inside parentheses is a reflection across the y. Outside is a reflection across the x-axis. And if parentheses are not given, they're not actually drawn in or stated, it's automatically assumed that the negative is outside. Because most likely what they're saying, if they're not included, is the same as saying negative x squared is equal to negative parenthesis x close parenthesis squared. Because if there's not a reason to have them, we don't put them, but these are the same thing. Questions on this one here? No idea why I have that started with homework questions. But we are continuing on with this here. Now, what we've been looking at, this quadratic equation, a parentheses x minus h squared plus k, is what we call a quadratic in vertex form. Vertex form of a quadratic equation. Now, when we went over equations of lines, we said we had point slope form. Well, the reason they call that point slope form is with it had a point and it had a slope. They called it exactly what it was. Slope intercept form, they called it slope intercept form because it had the y-intercept and the slope. The same thing is true for this here. We call this vertex form because the vertex for any quadratic equation is the point h comma k. In vertex form, we have the h and k values. Now, when we pull the h value out of the vertex form, we have to flip it because it's minus, so we change the sign. Because if it was positive or x plus 4, h comes out as negative 4. If it's x minus 7, it comes out as 7. It gives us the vertex. And A is going to be our vertical stretch or shrink, but it gives us the vertex. And the vertex is the biggest or smallest point on a quadratic. The biggest or smallest. You don't have to write this down because this, again, is stuff that we've had up to this point. We've seen this several times. I wrote this out yesterday. Because A indicates reflection in the x-axis and or a vertical stretch or shrink. That's what we've been covering. H indicates a horizontal translation left or right. And K indicates a vertical translation up or down. And what we're going to do is apply these transformations. Really, that's what we're doing. And we're going to leave it in vertex form. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation of 3 units down. Write a rule for G. Now, just like with the last chapter, I'm not too focused on what your function at the end is labeled. If you do label it as g of x, awesome. If you label it as n of x, that's fine too. And again, just like what we did before, whenever we have multiple transformations happening at once, we do them one at a time in the order that they are listed. So the first one is a vertical stretch by a factor of 2. Now our vertical stretch by a factor of 2 is our a times f of x. A times f of x. And what's our value of a going to be for this here? It will be 2. Because they tell us that we're going to take a vertical stretch by a factor of 2. And our vertical stretch or shrink is our a f of x. F of x is still f of x. We didn't change anything inside the parentheses, correct? So the function stays the same. Well, the function was f of x equals x squared. So we'll plug it in with parentheses and then simplify where needed. Well, we can just multiply these two and get x squared. Questions on how we got to this point here? We'll keep with g of x. I'm just going to call this h of x. Because again, h of x, g of x, m of x, n of x, this is just another way to name the function. Vertical stretch by a factor of 2, done. The next one is a reflection in the x-axis. And our reflection across the x-axis is our negative f of x, because that's how we define them all in f of x. Negative in front of the function. But our function we're talking about this time is h of x. So we're saying negative h of x. And just like the first one, we didn't do anything to f of x. We haven't done anything to the x inside the parentheses. It's still h of x. Which means just like the previous one, we can replace h of x with 2x squared. Questions on this here? Questions on any of this here so far? Now at this point we can simplify. We can multiply the negative in 2x squared, which gives us negative 2x squared. Someone give me a name for this one. J of x. Reflection in the x-axis. Done. Then we have what? 3 units down. So our up or down is we take the function we're talking about, in this case j of x, and add k to it. Now just like with the vertical translation, we do need to plug in a value for k. We didn't have to do it with our reflection because there is no value to plug in. It's taken care of by the negative. So the 3, yes. Right. It would be plus negative 3, or we can say minus 3. Either work. And now we need to plug our function in, or plug it into the function. But again, we still have j of x, yes? Since we still have the j of x, what realistically we did, I just didn't say it in the first two, is we replaced x with x, which doesn't change anything, so j of x is still negative 2x squared minus 3. Nothing's changing. We're just replacing the function j of x with what it's equal to. Questions before we simplify? So at this point, we can drop the parentheses and combine like terms. Well, there are no like terms to combine because negative 2x squared and negative 3 are not like terms. So we leave this here. But that's it there. Questions on any of this here? We're ready for the next one. And again, with any of these here, we take it one at a time until we've done all the transformations. So let the graph G be a vertical shrink by a factor of 1/2 and a horizontal and a translation 2 units up. Okay. Vertical shrink of 1/2 followed by a translation 2 units up. So our vertical shrink of 1/2.
May I have your attention, please? It is now time to release the softball girls to go to the new gym. Softball girls, go to the new gym at this time. Thank you.
So vertical stretch or shrink is still a f of x. Doesn't matter if it's a stretch or shrink, we still use the same notation for this here. Except this time, the value of a is 1/2. We have f of x, which is the same as our function, so we don't have to plug anything into our function f of x. We can just replace it with x squared. And last but not least, to simplify, we'll do 1/2 times x squared, which is 1/2 x squared. I'm just going to call it h of x. First step done. And a followed by translation of 2 units up. So our vertical translation is our previous function, which we called h of x, plus our k. Because I'm just using h of x because that's what we called the function after we did our first transformation to it. Now our value of k is what? 2. Would it be positive or negative? It's going to be positive since we're moving up. Just like the last one, we called it negative because we moved down. Now again, looking back at this here, h of x, we still just have x inside the parentheses. We don't have x plus 4. We don't have a number with it. It's just x, which means I can just replace it with the 1/2 x squared. And last but not least, we can simplify it. Yes. Questions on this here? I think we're starting to feel a little more comfortable with these transformations. Again, I say comfortable, not masters, because it takes a while to get used to these here. Questions on any of this here? Let the graph of G be a horizontal shrink of 1/3 and a reflection in the y-axis, followed by a translation of 2 units up. I need to go back and fix this slide and make this a lot smaller. So the first one is a horizontal shrink by a factor of 1/3. Now our horizontal stretch or shrink is our f(a) of x. F of a times x, not of x. F of a times x. Now we do need to plug in the value of a. So we look back up here. Horizontal shrink by a factor of 1/3. I believe I heard multiple people, I think, say the same thing. But we have to do what to the 1/3? Flip it, which turns it into a 3. So the value of A here is 3. And horizontal stretch or shrink is the only transformation we have to do this to. It's the only one we have to do this to. So we have f of 3x, yes? Well, unlike the last two, do we still have x inside the parentheses? Yeah. Well, we do, but we also have a what? Now, our function is just saying f of x equals x squared, yes? Whenever we replace the x inside the parentheses, every x in the function has to be replaced with it as well. The rest of the function will stay the same. We're just replacing x with 3x. So instead of having x squared, we have 3x squared. Now, if there were other numbers to it, if it would have said 2x squared, it would have been 2 parentheses, 3x, close parentheses, squared. Everything else stays the same. We're just replacing that x with 3x. And I'm just going to give it a name. I'm going to call it h of x. Yes?
So on the last question, we put this x, like squared with the x inside the parentheses.
Yes. So this one here, really what we're doing is plugging in 3x for the x itself. So the x here is to the second power. So when we replaced it with 3x, both the 3 and x are the second power. And I'm going to go backwards a little bit. So the reason we put the square outside, because what you're asking is why do we put the square outside the parentheses for this one here? And on the previous one, we put the square inside. So here, the square is on the inside because I'm just replacing h of x with its function, the whole thing, the 1/2 x squared. On this one here, we're replacing the x in the x squared. So this piece here with 3x is taking its place. So the square is still staying put, but we're applying the square to not just the x anymore, but to the 3x. Does that make sense? I think a similar example would be as if I said f of 1. Because y'all have seen this before, Algebra 1 a little bit. When we had this, we plugged 1 in for every x, yes? So in this case, if I plugged it in, we would have 1 squared. And then we'd simplify from here. But in our case, we're doing the same process. Same setup, same rules, but instead of having 1, we have 3x. Does that make sense? Yes? If that's a little bit confusing and you understood it already, ignore that. But that's all we're doing. Now, at this point here, we can leave it as 3x squared. We could simplify it, and I will show you guys that here in a bit. But that is the horizontal shrink of 1/3. Gives us parentheses 3x close parentheses squared. We don't have to simplify it. We can leave it as this here. Followed by a reflection in the, yes, so we have h of negative x, because we called it originally f of negative x for our reflection in the y-axis. But here we're just calling it h of x because we're talking about this function here. Well, we have h of x is this parentheses 3x close parentheses squared. And just like how we got here, we replace the x and f of x with 3x. This time we're going to replace the x and h of x with negative x. So that will give us, we still have our parenthesis, we still have the 3, but the x is now what? Negative x. Now we will remove those parentheses because it's not applying a power of 2, we're not multiplying it out. We can drop those. But to do that, What's 3 times negative x? Negative 3x squared. Because we multiply those two together, because doing that multiplication is fine. I'm not making you actually factor that thing out. And we can call this z of x. So we took care of the reflection across the y-axis. Questions on any of this here? We good with this here so far? And the last one was up to. So we would add 2. So z of x would equal, or not z of x equals. So z of x plus k would be what we have. And again, because it's up to, we're just adding 2 to the function. Yes, since now this is the first one for this problem, we just have x inside the parentheses for z of x, which means I can take its function, negative 3x squared, and add 2 to it. Now, realistically, I could put parentheses around it, but I think at this point that'd be a lot of parentheses. It might be a bit confusing. But that would be our final answer. G of x equals parentheses negative 3x close parentheses squared plus 2. Can we make it more simplified than that? For this one here, yes. Because I'm not going to ask you to do this next part. Let me get purple. The writing utensil. Because here, 3x squared, we could have simplified this because it's one term. Because 3x times 3x, that's what a square is saying. We're multiplying it by itself. 3x times 3x is 9x squared. The 3 times 3 is 9. X times x is x squared. So we could have simplified that. Which would mean when we applied the negative, it would have been 9 negative x squared. And again, this is above and beyond. You don't have to do this, and if this is too much, do not worry about it, okay? I'm not asking you to do all of this here. Now, our negative squared, x squared, just like our 3x, we can multiply by itself. Negative x times negative x is just x squared, and when we add 2, we get 9x squared plus 2. So 9x squared plus 2 and our parentheses negative 3x close parentheses squared plus 2 actually are the same function. But I will take this here. I will take the one in red. Or the one, I'll take either one. But I would stick to the one in red because if we have a horizontal translation left or right, we can't just drop those parentheses. We'd have to actually multiply it out. But so the x is still, it's just not attached to the 9 anymore.
So you got the 3x squared out of the way. You've got to square the x.
Yeah. Makes sense. Questions on this here? Hope.
In that case, would you, let's say x is 2, for example. So would you do 9 times x and then square it, or would you?
So g of 2 for either one. So we can say the bottom one 9 times 2 squared plus 2. And again, order of operations says exponents. Parentheses first, and when we say parentheses, we mean anything inside the parentheses. So there's just 2, so that's simplified. Then we follow it up with exponents, and 2 squared would be 4. And now this is where it normally breaks down, and this is why Facebook or social media has so many questions with order of operations. But the best change that we've had in the last few years is with order of operations, the way we explain it. Multiplication and division from left to right. So we start at the leftmost part of the equation, left or right, whichever multiplication or division comes up, we do it from left to right. So going from left to right, we have 9 times 4, which is 36. We don't have anything else, so we have plus 2. And lastly, 36 plus 2 is... But that's it. Questions on any of this here? Now again, the forms that you had for the test, that a of f of x plus k, f parentheses a times x, those still work for this here. And I would still refer back to them. And on the test, I would still include those on the review sheet. I will look back at it again and make sure, because if they do show up, I will state it so that you do know to put them on there. If not, I will tell you. And that is it. Now again, with any of the assignments that we have here, you are not graphing. I'm not asking you to graph any of these here. Right. Yes. So 3 through 11 odd, describe the transformation. That's all you're doing. 3 through 11, describe the transformation. Yes. 17 through 21 odd, describe the transformation. You don't have to graph it. 27 through 29 odd, or 27 through 29 all, describe the transformation of the graph of the parent quadratic function. Then identify the vertex. Now, vertex, we didn't specifically say this in the lesson, but it's h comma k. H comma k. Now, talk about this briefly, because whenever you get in vertex form, here where we have the function, the h value inside is the h value of the vertex. Like with most things, we have to flip the sign. So if it's negative inside the parentheses, it comes out as positive. If it's positive, it comes out as negative. And k is exactly what it looks like. So up or down. Let's snag this. So this is 27. I'm not going to do the description of the transformation. We're mainly looking at the vertex. So the vertex for this here, well, the value of k in this case is positive 1. So we just put it down as 1. Right. Well, I'd have to look back at it. But the other part is the plus 2 inside. The h value would be 2, but since it's plus exactly, it would be negative 2. If there are no parentheses, it's just x squared, which means there is no h. There is no movement left or right, so the h value is 0. If there is nothing added, there's no number in where the 1 is for this one here, it is 0. If there's not a number in either spot, they are both 0. It's based off of that, but if we look at the original form, it's x minus h, yes? So the only way we could change this minus to a plus is if the value of h is negative, because we get the negative negative. And again, this is just my own personal opinion. I think it's easier to think of it as the opposite than to rewrite the formula, or rewrite this function as 3 parentheses x minus negative 2, close parentheses squared, plus 1. Rewrite it back as that minus negative. Does that make sense? And if that is helpful, if you do find that helpful, rewriting it back as x minus negative 2, then do that. Yes. Yes. So describe the transformation. So our up, down, left, right, vertical stretch, vertical shrink, horizontal stretch or shrink, and our reflections. So what we've done throughout most of the lesson, except for we're not applying the transformations. So it's everything else. Does that make sense? So the 3, so we'd start with the +1, which is up 1, left 2, and then a vertical stretch of 3. That would be the description or describing the transformation, and then we include the vertex of -2, 1. So that's all it's asking for.